Alright, so this right here is steps 5 and 7 for the project. Step 5 just really wants us to review these videos and basically just summarize them and what they talked about. This first video right here of airflow measurement, this one just talks about like what the whole projects are going to be about. It's just basically about like measuring the flow and getting a velocity measurement from the wind chamber that's right there. Basically right here is just talking about, you know, the equipment that's going to use. That's the same equipment that we use for our wind tunnel assignment to get the flow on the exit and the entrance. So yeah, so it's just explaining here how you would have to get the velocity at each corner of the chamber, and I believe you use that to get the average velocity of the whole wind chamber. So that's video 1 of airflow measurement. The second video is airflow restriction. So beginning of the video, it just talks about how you would restrict the flow to do Reynolds number. We're excluding that part for this project just because we're not dealing with the Reynolds number yet. But yeah, it's just talking over the steps of how you would restrict the flow when taking a measurement. So it does say to not cover the entrance 100% fully. And here you'll see how, you know, he puts some box in front of the entrance, but it's not covering the whole entrance entirely, but still that still provides a restriction. So yeah, then once you take your measurement of the flow, you will realize that it will decrease the flow and you'll get a much smaller velocity. Now the third video, this one is about drag measure flows, the drag measure flow of the sphere. So in the first part of this video, it talks about just how you will set up the sphere in the wind chamber. And right here he has rubber bands that are holding up, you know, a fishing, I believe it's like a fishing line, and you know, he's using that to, you know, carefully place the sphere just so it's in a secure position and it won't move. So that's what the first part of the video is talking about. This one, what he's doing right now, right here, he's taking top and bottom measurements of the velocity. So he's taking 3 measurements for the top and the bottom, and then he will average those to get his average velocity. And then once he has that, when he takes out the force sensor, and now this one is used to get the force of the sphere. So right here, you know, showing him a video of him setting up the sphere with the fishing pole. This is how it's gonna look, you know, the front view of it. So he's gonna place the force sensor on the side, and then yeah, that's how he sets it up. And that's when you would have to take the force measurement 3 times, just like how we did with the velocity, and get the average force. And then this next video right here, this one's the drag measure flow of a cylinder. So, you know, for the cylinder, you're gonna take 2 profiles measurements. So that profile right there, and then that's one right here. So it's kind of like a circular profile, and the other one's gonna some will be like a rectangular profile. So this video right here is very similar to the sphere video. Basically it just shows how he will set up the cylinder in the wind chamber, same way, you know, with the rubber bands and the fishing wire, the fish wire. You know, that's where he has that one. First he has that circular profile. You know, he has the force right there. He takes the measurements. I believe he's taking 3. Take the average. Once he has that, get the other profile, you know, and then take 3 measurements just to get the average. And then the last video is the drag measurement for the block. So this, just like the cylinder one, this one has two profiles as well that we're gonna take measurements of. One, that's the first, oh sorry, this one right here, that's the first measurement, you know, from this view right here. This one's the length times the width. No, this one's the length times the depth. And then right here, that'll be the length, no, the length times the width. Yeah, so that's what he's about to do. You know, a lot more of the last two videos where it just shows you how to set up the block while it's in the wind chamber. You know, same way you have it against the force sensor. Take a measurement, switch up the profile. Right here is showing you how to set it up the other way. You know, with the rubber bands, you move it around with the fish wire. So this one, this right here is just showing how to set it up in the wind chamber. You know, and then once he has it set up, it's just trying to get it precise as possible, you know, just to get a good measurement. So yeah, and then you get the force sensor and take that measurement as well. Now for steps steps 6 and 7. So right here in the assignment, it wants us to calculate the force on each profile from the addition of the air mass, and it asks us to look at the example problems for a hint. And then once you get the force, you compare it to the measured force from the data that was provided. So right here I have a PDF of my work. So we'll start off with the sphere. Now here's the mass, here's the diameter, and then this right here, the 1.225 pounds over feet cubed, that's the density of air that I used from my previous steps 2 and 4. So I'm just using the same one just to be consistent with it. So yeah, right here is where we have the velocity, the measured velocity, and the measured force. So we'll be using this equation right here to get our force, which is gamma over gravity, which will be 9.81 times the area times velocity squared. So for all of these, the gamma over gravity is going to be the same. The velocity changes for each force, and then the only different ones is going to be the area. So now our group had a problem with the area because we weren't sure of how to, we got it for the spheres, but for the long side of the cylinder and for the block, we were not sure how to calculate like the correct area. And also we were also unsure how to you know, also include the mass into our force. I was thinking of just, once we get this calculated, just add the mass to it, but that wouldn't give like an inaccurate answer. So again, so this is what this equation that we used to solve for the sphere area. I got pi times diameter squared. This what we got. The first one is our most accurate one, because if you look at the measured forces to the calculated forces, you can see that it's super close in value. For the golf ball, the first two forces were pretty off from the measured, but the last two, they were pretty close. Now for the cylinder long side, I use the equation just length times diameter, basically just, you know, the area of a rectangle. So this right here, this where it starts getting, you know, kind of funky, where the calculated forces are way off from the measured forces. Let me go to the circular sphere diameter, and you know, we use the same equation as the sphere, which is pi times diameter squared. This right here, I mean, some were pretty off. I mean, for example, this one right here, if you were to round it, it'll be 0.01. This one is 0.018, kind of close, but not really. And then now for the blocks, the areas for this, for the small block, I use length times width. For this one, I use depth times width, kind of similar to the last video. you know, this video is from step 5. Also with the cylinder one, you know how we have 2 different profiles that we're gonna take measurements for the force. So this was one of the profiles and the small block was the other. So yeah, so I mean, we look here at the calculated forces. You know, it's not close at all. Also for this one, not that close. I mean, this last one, if you were to round it, would be 0.01. This one again, like how the previous problem was 0.018. So yeah, so our forces were not close. Our calculated forces were not close to the measured forces, except with the spear, the very first one. This was the only accurate one that was super close in value, but the other ones were not as accurate. And then step 7 just wants us to create a linear function from the measured force versus the velocity of each profile. I used the measured force instead of the calculated force just because they were not accurate, but you know, right here you can see like some of a pattern. We see this spears. Some of the spears have like this curve right here. You know, have a big curve. This big curve right here is from the large block, while the small block had a different, you know, behavior. This yellow and blue one, which is a cylinder circular, and the blue one is a spear, had a similar behavior, which they're both spheres, so it makes sense. And then the golf ball and the cylinder long side also had, you know, similar behaviors. Yep, and that concludes steps 5 and 7 for this project.